I've got this little scene here that comprises of a terrain and some Bryce primitives, and I want to capture this little setup as a height map, and then I want to be able to apply the materials. So this is what we're going to go through now, just the mechanics of the process, and then afterwards probably talk about some of the issues. So to start with, we don't need 48-bit dithering when we're capturing the altitude mask because that introduces noise, and you definitely don't want gamma correction checked because that changes the linearity of the height map. So this is the altitude masking that we're going to use. So if I now engage that and just give it a quick render, you can see that we've not got fully black where the ground plane is. So that's like wasted information. We've got white where the top of the terrain is. And so to correct for that, what you need to do is take your entire selection that's going to be incorporated, group them, and then change the group origin position to 0, and this will mean that you get full black where the lowest object is and full white where the highest object is. So we're getting the full range on the height map. We're not wasting any information opportunities, and that's important because this altitude mask only produces a height map of 8-bit resolution depth. You can't get around that, that's just the way it works. And the terrain editor accepts 16-bit depth, so there will be some steps in this, which is annoying but inevitable. Okay, I'll cover why there aren't other ways to do this in a bit. Now the camera needs to be set so it's directly above our scene, and I'll rotate it so it's facing down. Now if the camera is too close to the scene, like this, you can see we've got perspective. The reason I'm not using the overhead camera is if we've got an overhead view camera you can do this from, so like overhead view cameras around here somewhere, which is far enough away to eliminate perspective. But when I change the aspect ratio of the scene, so if I change this to 1:1, which is going to be square to suit the setup, the render no longer aligns with the wireframe view, and there's still perspective on this. We can just produce a similar effect by putting this camera up and then narrowing the field of view. So if I put this camera up in the air, so it's a long way away, and then I can just narrow the field of view to bring our scene back in again to where we want it, like so. So that's brought it in, and you can see that it's aligning with the wireframe view, so we've got a better guide. So that's made it a bit big, so I can always just increase the altitude of the camera, and by drawing it back like that we can more or less position it where we want. If you want to know where the actual overhead camera is, press 2 shortcut for the overhead camera, and you can go edit current camera, and that actually put the perspective camera above the height of the top camera. You'll also notice in the wireframe view you'll have trouble selecting objects that go beyond the range of these orthogonal cameras. So now we're actually in a better position for elimination of perspective than we were before, and we can capture our altitude mask. So file, save as, alt mask 1, and then if we just turn the altitude mask off, you can see that the scene's looking a bit washed out. Now by default the overhead camera, so that's the overhead view, is not influenced by the haze, so that's a different property of these cameras. So if we go to the perspective camera and go to the Skylab here and hold the Alt key down, we can disable the haze setting, and that will allow us to capture our render. It's obviously these shadows are going to end up being baked onto the terrain as well, but we'll not worry about that. It's up to you how you set your lighting up. So I'll call this textures. Right, I now need to open a separate instance of Bryce and to import the terrain height map. It's fairly easy. Now I suppose to optimize this, I've done this at a resolution that coincided with the resolution of the terrain height map. So imagine that at 1024 or 512, because otherwise we're either going to be stretching pixels or losing information. But if I just create a default grey terrain by holding the control key down and clicking on terrain and edit, you see this set resolution is 512. So if we load in, use picture, load in the height map that's been created here, that's our height map of objects, and then I can check out of that and go into the material lab now and I'll use the ambient channel and the diffuse channel together and go to picture and load in the image that I created. There you go, and then that's parametric map, so that'll appear on top of my terrain. There we go. I'll just move the camera in and you can see that that's got its mapping. So some things you may notice. This was a sphere on the original scene. Okay, I'll get back to, this is where we started. This was a sphere, so if I look on the side, that's going to be a sphere. And now if I look on the side of my terrain, and the wireframe view is not very high resolution, so you can increase the resolution of the selected wireframe view for this job. This is not a sphere, so the height needs adjusting so that matches a sphere shape. So you could do, if you know there's set objects in there or bring the objects in, you can use this as a guide to get your shape right. So you've got it scaled appropriately, like so. So that's just a hint there to get it back into the right kind of scale. So obviously the underside of this, because it's a height map, it can't be aware of that, and the sides of the objects here, because they're all almost vertical but not quite, they're encountering the area where the pattern was, so it's not a perfect system. So difficulties in making it more perfect. Right, the resolution. I tried different approaches to capturing this, like putting it in black fog and also setting up lights around it, setting up a rainbow set of lights around it to try and create, say, a normal map that could then be converted. But very difficult to set this up so that it produces the right normal map for a sphere. I didn't manage that, and again the colour resolution was letting me down, so I realised this wasn't going to be a solution to solving the resolution problems for this little project. So I'm afraid, as things stand, you're stuck with the 8-bit resolution of this terrain height map. You can smooth it, obviously. You can see there's a few dimples in there, and also if you know that it's 8-bit resolution, then having a very high resolution height map in the other dimensions is not really going to help you. You're just going to see steps, but you can save the image at a much higher resolution. So you could capture your image at the height map at 1 resolution, and then up the resolution for the image, so you could still have a nice high quality image on a lower resolution height map. The idea behind this, of course, is you could create complex geometries using instance shapes and then capture them as height maps or convert them to lattices to have a smaller memory footprint. As far as exporting is concerned, this is something I was looking at, no, not in there, in the train lab. None of the export options here for export image allow it to export an image at, or at least reliably, at any 16-bit resolution. I get the impression occasionally it does it, but it doesn't seem reliable. It seems to export always at 8-bit resolution. These export formats here as meshes, the OBJ format works very well, but obviously you've converted it to a mesh. PGM file and DEM files worked fine. This HF file format didn't produce any sensible output. So some of the height map formats do work, but the importer for the picture is very particular about what it accepts in, and it won't necessarily accept back what you've exported out, but other software will accept it. What you need for the picture ideally is either 16-bit grayscale TIFF or 16-bit grayscale PNG. The PNG definitely works. The TIFF, I recall from the beta testing, was the other specification, but there's not much software out there. I mean, I know that PaintShop Pro won't do it, and I just tried Project Artist and that doesn't seem to handle it. The 16-bit grayscale resolution seems to be quite a rare format, so all in all it's a problematic thing passing these height maps around between Bryce and other software. If you can Control C and you can paste this height map into other height maps in another instances of Bryce. And you can paste it into some other bits of software as well. It will paste into Crazy Bump, for example, which was a bit of a surprise. But you can't take the height map from Crazy Bump and paste it back into the train canvas. It doesn't like the format. So there are issues in these things that you need to be aware of. So there you go. There's a bit of an explanation and a bit of an experiment on what I've been looking at recently, and that is the export and import of terrain height maps. So I hope some of you will find that information useful, because it took quite a long time to work it all out.